Okay. So here our aim is to find the band gap of intrinsic semiconductor material. సో సిలికాన్ జర్మేనియం లాంటి మెటీరియల్స్ ఏదైనా తీసుకొని దాని బ్యాండ్ గ్యాప్ ఎంత ఉందనేది మెజర్ చేయడం ఎయిమ్. ఓకే, బట్ the material we are choosing is a p-n junction diode. So there the material is doped with some additional elements like pentavalent elements or trivalent elements. So then how to probe a particular intrinsic semiconductor carriers is a matter of interest now. So when we are dealing with it, we must only excite or we must identify the minimum energy required to excite an intrinsic semiconductor electron. So first of all, we have to choose that particular intrinsic semiconductor electrons only, and then we have to identify the least amount of energy required to excite. So then, before going into that, we must know how an intrinsic semiconductor changes when it doped with p-type. When you try to make it a p-type material and n-type material, is a matter of interest. Okay. Right. So I'll go into a little more detailed way. So I'll start with basics of what. So the periodic table, what are the elements that are stable? The elements that remain stable are noble gases. Means what? 8 group elements. Why 8 group elements are stable? Fully filled electronic configuration. So then comes the question, is it really fully filled? Right. So the maximum number of electrons in a given orbit is given by 2n square. So in the first orbit, how many? 2 electrons, 1s2 ఉంటుంది. Second orbit లో 2s2 2p2. Third orbit 3s2 3p6 3d10. So like that, the number of electrons in a given orbit increases as a function of n square. Right? So the first orbit maximum occupancy is 2, second orbit 6, third orbit 18, fourth orbit 32, fifth orbit 50 electrons. Maximum number of electrons in a given orbit. So then why are we confining to only 8 electrons? Why do we say octet configuration is stable? ఎందుకంటే 6 18 8 కదా ఇక్కడ 8 ఇలా కౌంట్ పెరుగుతూ ఉంటే 8 దగ్గర ఎందుకు ఆగిపోయాం మనం? వేర్ వి స్టాప్ ఎట్ 8. The reason is Ahbab principle composed by both. Aufbau means about building. Of building. Aufbau. It's not the name of scientist. In German, Aufbau means of building. Aufbau principle. Building of atoms. How atoms are built up. అనే దానికి ఏం చెప్తుందంటే ద ఆర్డర్ ఆఫ్ ఫిల్లింగ్ ఇట్స్ లైక్ దిస్. So what is the order? Yeah. So you cannot mark it like this. You have to start from this end. One is from this end. What do you get? What is the order? What is? పని చేయట్లేదు. అబో ప్రిన్సిపల్ చూడండి ఒకసారి. ఓకే, సో ద ఫిల్లింగ్ కమ్స్ ఫ్రమ్ దిస్ ఎండ్. 1s, 2s, 2p, 3s, 3p, 4s, then 3d, 4p, 5s. Okay, so in this direction. So order చూడండి, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, this is the order of filling. So whatever completely filled orbit and completely filled atoms with completely filled orbits are stable. Basic rule. Now if you see what is the maximum number of electrons in the valence shell is a matter of interest. Outermost shell లో ఎన్ని ఎలక్ట్రాన్స్ మనం ఫిల్ చేయగలము అనేది చూస్తే, సో వన్స్ దిస్ 1s is filled, first shell is closed, and after 2s and 2p the electron enters into third shell, and after 3s and 3p electron enters into fourth shell, then 4s, 3d, 4p, after 4p electron enters into fifth shell, then 5s, 4d, 5p, after that it enters into 6th, 6s, 4f, 5d, 6p, then electron enters into 7th shell. So at any point of time, the maximum number of electrons in valence shell, outermost shell, is how much? Even though the third orbit allows 18 electrons, after you fill 2 plus 6, 8 electrons, electron enters into fourth orbit. And after you reach 4p, 4s and 4p, electron enters into fifth orbit. So at any point of time, the maximum number of electrons in outermost shell is limited to 8. So the shell allows more electrons. In the outermost shell, the maximum limit is 8. So that is why if that limit is attained, the atom is said to be stable. Okay, so octet configuration is stable and all atoms try to attain octet configuration, because that is a maximum limit that we can fill in the outermost shell. And outermost shell is responsible for all bonding, electronic, chemical reactions and all. So all we bother is about only octet configuration. Okay, so ఇప్పుడు ఈ ఫస్ట్ గ్రూప్ ఎలిమెంట్స్ తీసుకున్నట్లయితే సోడియం, lithium ఉంది, sodium, potassium, all these have one electron in excess. So they simply give out that electron and become stable. And if you go for seventh group elements, fluorine, chlorine, bromine, iodine, they require one electron. So they try to grab one electron and become stable. So in other words, these two exchange electrons and form ionic bonds. So that is one way of getting stability. Other cases also, like these atoms. Beryllium, magnesium, calcium. So second group elements, they try to make bonds with sixth group elements. So like that they become stable by forming ionic bonds. But coming to this fourth group elements, they have 4 electrons in hand and they require 4 more electrons. So they can't give out all the 4, or they can't grab 4 electrons when they are at the middle stage. So then how to get stability is a matter of interest. అంతే కదండి, 1, 2 అంటే ఏదో వదిలేద్దాం, ఫ్రీ అయిపోదాం అనుకుంటే, ఇక్కడ 1, 2 కాబట్టి ఎక్కడైనా తెచ్చేసుకుంటే సెటిల్ అయిపోదాం అనుకుంటాం. బట్ ఇది ఇద్దామంటే 4 హాఫ్ ఫీల్డ్ ఉంది, తీసుకుందామన్నా సరే హాఫ్ ఫీల్డ్ కావాలి. A tough task. So what they do is they share the electrons among themselves and form covalent bonds. So ikkada varaku ionic bonds untayi, but this group forms covalent bonds. Okay, so now how do they form? So carbon has 4 electrons. It forms bond with another 4 carbon atoms. So this atom sees all the 8 electrons in the valence shell. So each atom has 4 electrons in the valence shell. And once if they start sharing among themselves, they form 4 bonds each. So the atom becomes stable. The material becomes stable. So then what is the status of this? So if you have carbon, consider carbon here, the electron configuration is 1s2, 2s2 and 2p2. They form covalent bonds. So if you see the energy level diagram, so I draw an energy level diagram here. So energy of one carbon atom may look like this. This is vacant, and this is half filled. I mean, this may later become 2s1 and 2p3. So the second orbit is half filled, later it is vacant. And if I take 100 such atoms, the energy level diagram remains the same. All the 100 atoms will have energy levels at the same state. Because that's a simple graph. If I take 100 carbon atoms, they all will have energy levels at the same location. So then, once they start forming bonds, the bond formation process redistributes the energy. Energy will be redistributed. Some of the atoms will lose energy and some atoms will gain energy. There will be a redistribution of energy. That leads to bands. So energy levels now become energy bands. So this is completely filled, this is half filled, and this is vacant. This is empty band, half filled band, and this is filled band. So now, since this is called valence shell, this is called a valence band. And the corresponding next level is conduction band, the lowest unfilled band. Right? So now, what happens if I give a potential here? If I connect this material to a battery, what happens? Some of the electrons may gain energy. Electrons will be pushed from this end, and they will be pulled from this end because of this positive potential. So what happens? Electron will gain energy and rise to conduction band. So in the energy level diagram, we represent the electrons shifting from valence band to conduction band. Right? So then, where does this electron go here if it shifts from valence band to conduction band? Suppose the energy I am supplying here is taken by this electron. Where will it go? I am saying the energy is rising from valence band level to conduction band level, but physically where will it move? ఇక్కడ బాండ్ లో ఉన్న ఎలక్ట్రాన్ ఎటు మూవ్ అవుతుందండి? కండక్షన్ బ్యాండ్ ఎక్కడ చూపించాలి? So it is going into conduction band, means it is actually the next orbit. So appadi varaku first orbit is second orbit lo unna electron, now it goes to third orbit. But this third orbit is linked for all the atoms. So it may be freely moving across the lattice. So up to second orbit, this electron is under the control of this particular nucleus. once it reaches the next level, next orbit, it may move from one atom to another atom freely because of this bond formation and overlapping things. Okay, so now if we give any attractive potential on one end and repulsive potential on another end, the electrons will start moving from one end to other end depending on the sign of the potential. Here the electrons will be repelled, and this end electrons will be attracted by the applied potential. Okay, so rising the energy does not mean a change in position technically. I mean, it may at most shift to next orbit, but that orbit is now overlapped with other atoms. So the electron now is free to move across the atoms. So that is the situation. So now, so here a hole is formed here. When I give energy, and the absence of electron in a bond is called hole. Absence of electron in a bond is hole. So now, what happens to? So if I take 1 electron volt bandgap material and I give exactly 1 electron volt energy. 1 electron volt gap తీసుకున్నాను, 1 electron volt energy ఇచ్చాను. So I can at most break a bond here and reach up to here. If I give little more energy, 1.1 ఇచ్చాను, ఏమవుతుందండి? The electron goes to little higher in the energy graph. If I get little more, so electron rises up and up if I give more and more energy. What happens to hole if I give energy? So I want to see the location of hole if I give the same amount of energy. I give 1 electron volt here. So the hole is generated here. If I get little more energy, 1.1 ఇచ్చాను, ఇప్పుడు నేను హోల్ ఇక్కడ నుంచి జనరేట్ చేయొచ్చు. Even more, I can break a bond at a lower level. So hole moves downwards if I give energy, the rise in energy. If I give more and more energy, hole moves downwards, whereas electron moves upwards. Okay, so that is one thing you must understand. And then there comes a Fermi level in between these two due to uncertainty. So though the valence band electrons may come up to this level, because of uncertainty they may reach to a little higher level, and that I call as Fermi level. It is the energy attained by an electron at 0 Kelvin. Without supplying any external energy, with zero supply of energy, the electron reaches to this level. That is the Fermi level. So this is all about intrinsic semiconductor. So now what happens if I dope with certain elements, pentavalent element? ఏం జరుగుతుందండి? I'll clear this. So now comes the case of doping. So now I replace the carbon atom with a pentavalent impurity. So there comes a 5th electron into picture. So this electron has all the positive and negative charges suitable for it, sufficient for it. So this material is electrically neutral but has an unbounded electron. Bond lo form avunnaటువంటి electron. still it is binded to its nucleus. And nucleus తో కావాల్సినటువంటి పాజిటివ్ నెగటివ్ చార్జెస్ బ్యాలెన్స్ అవుతున్నాయి, బట్ ఇట్ ఈస్ నాట్ ఫార్మింగ్ ఎనీ బాండ్. ఇట్ ఈస్ బాండెడ్ ఎలక్ట్రాన్ but not in bonds. Okay, so how to show the energy level of that? I call this as energy valence band and this as conduction band. So where shall we show the energy of that fifth electron? So if I give little energy, I don't need to break any bond, it will be ready for conduction. So its energy is nearer to conduction band. So all fifth electrons that I am doping here will have energy level here. So this is called donor level. అంతే కదండి, నేను కొంచెం ఎనర్జీ సప్లై చేస్తే దే విల్ బి రెడీ ఫర్ కండక్షన్. So now the Fermi level will come in between these two. Fermi level is a uncertainty correction for energy levels at 0 Kelvin. So now I dope it with trivalent impurity. So there comes a vacant space, vacancy in the bond. So vacancy in a bond is called hole. So where shall we show that hole? Energy level. So if I give little energy, the hole will be ready for conduction. It requires little energy, but where will that hole move, by the way? An intrinsic semiconductor, the hole moves in valence band. A hole moves in valence band. So in an intrinsic semiconductor, there will be two carriers. So if you give energy, this is a hole and this is an electron. Electron will be freely moving. So I created a hole, electron is freely moving in the lattice, and a hole also will move in opposite direction. So let's say if I connect a positive here, so electron will be moving in this direction and a hole will start moving in the opposite direction. Same అవుతుందండి, this negative potential will attract the hole, so hole will come here and the electron will jump to this location. So hole అనేది ఇక్కడికి వచ్చేస్తుంది, అంటే యాక్చువల్గా జరిగేది ఏంటి, ఎలక్ట్రాన్ అనేది ఆపోజిట్ డైరెక్షన్ మూవ్. ఇంకొకటి అగైన్ it may come here, further shift, another, the electron will come here, hole shifts here. So laga whole movement, it requires breakage of bond and creation of a bond. Okay, so the electron moves in conduction band and hole moves in valence band. So hole moves in valence band, electron moves in conduction band, and hole requires breakage and creation of bonds. Electron does not require any such. Once it is free, it moves freely. So I call it as like it is little difficult to move a hole compared to electron. So I represent it as effective mass of hole is more than effective mass of electron. Effectively, I feel hole as heavier compared to electron. So this will come in your solid state physics. So the effective mass of hole is heavier compared to electrons. So in solar cells and all, we prefer N-type material. N-type material is heavily doped. So for solar cells, we have N plus P junction. So N is heavily doped, N plus and P junction. And for LEDs there are different cases. Okay, so we have to alter this depending on the requirement of carriers. It is difficult to move a hole in a valence band and easy to move electron in a conduction band. So here technically this power moves in a valence band only when I give a little energy. So where shall I show its energy? If I give energy, hole moves downwards. So the energy level of holes will be nearer to valence. If I give energy, they will move into the valence. So this is called acceptor level. And this is the Fermi level. Okay, so for N-type material, Fermi level is nearer to conduction band, and for P-type material, Fermi level is nearer to valence band. Now if I join these two, what happens? I'm joining a P-type material with an N-type material. So this is valence band, this is Fermi level, this is conduction band. And for N-type material, valence band, Fermi level and conduction band. So on P side, the maximum level an electron can go is up to here. On N side, electron reaches up to here. It is easily approachable to this level due to this doped electrons. Okay, so now when you join two atoms with different energy levels, they get balanced. And water tanks ni join chesina sare at different levels will balance. So Fermi level among the Fermi level balances. So we have to shift all the other levels according to that. Fermi level balances. So valence band comes here on P side and conduction band comes here on N side. This is the band diagram for PN junction. And here we have holes, and here we have electrons. Okay, so if I give a positive potential, I mean I'm trying to forward bias this diode, what happens? I'm pushing the electrons from this end and pushing the holes from this end. I'm giving energy. So electron will rise up and hole will sink down into the valence band with the rise in energy. And then I can assume electron has a metal ball on a surface. I mean rigid surface. Whereas hole has a plastic ball in water. If I give energy, it moves downwards. If I don't give energy, it simply floats. So this is a plastic ball in water tub anukuntanu. It is a metal ball in a ground. So if I give more and more energy, if I give sufficiently larger energy, it will shift to this level. So that is why up to some 0.7 volts, no conduction in forward bias. After that, carriers will start moving. Okay, what about reverse bias? So I am trying to give a reverse bias to this. So I am giving negative potential on P side and positive potential on N side. What happens? All the holes will be attracted all the electrons will be attracted. No dope charge carriers. మనం డోప్ చేసిన క్యారియర్స్ అన్ని కూడా మిస్ అయిపోతాయి. ఇంకా క్యారియర్స్ ఎక్కడి నుంచి వస్తాయండి? అవి ఎక్కడి నుంచి వస్తాయి? So here let's say I doped with 1000 phosphorus atoms. And at that particular room temperature, let's say some 5 electrons are broken bonds under this level. So I get 5 holes and 5 electrons. So 1000 electrons are readily available from dopant atom and 5 electron hole pairs are generated due to temperature. Okay. What about here? I have 1000 holes and then 5 electrons, 5 holes. So total count ante? I have 1005 electrons and 5 holes. So these are the majority carriers count wise. ఎక్కువ ఉన్నాయి ఇక్కడ. Electrons are minority and holes are majority. సో ఇందులో కంట్రిబ్యూషన్ ఎక్కడి నుంచి వస్తుంది? ఒకటి మనం డోప్ చేసిన ఐటమ్స్ నుంచి వస్తున్నటువంటి క్యారియర్స్ ఉన్నాయి. రెండవది ఇంట్రిన్సిక్ మెటీరియల్ బాండ్స్ బ్రేక్ చేసుకొని ఇంత ఎనర్జీ గ్యాప్ని క్రాస్ చేసి వస్తున్నటువంటి క్యారియర్స్ ఉన్నాయి. రైట్? సో ఎట్ రూమ్ టెంపరేచర్ దెర్ విల్ బి లెట్స్ సే సమ్ 5 electrons here and 5 holes readily available in valence band. Okay, ante I'm here showing only the dopant electrons and holes. What about intrinsic carriers? There will be holes available readily here and electrons available readily here. Ikkada entandi there will be holes here and electrons here readily available. So ikkada kuda ade there will be 5 holes and 5 electrons readily available. 5 holes, 5 electrons. Now if I reverse bias, these electrons will be pushed and I don't need to give any extra energy because it is easy to travel downwards for electron and easy to travel upwards for holes. Holes easy ga paiki move ayipotayi, electrons kindaku move avadam easy. So, in reverse bias, if I give a little potential, current starts conducting, and that number is the maximum. Whatever నేను ఇక్కడ 5 electrons ఉంటే ఆ 5 వచ్చేస్తాయి, and it won't change further. The current remains constant even if I raise the voltage. నేను 5 పెట్టినా 10 పెట్టినా 100 పెట్టినా కానీ current remains constant, and the current is 1000 times lower compared to forward bias. ఇక్కడ 1005 electrons ఉంటే ఇక్కడ holes 5 ఉన్నాయి. Now the conduction is only due to these 5 electrons and these 5 holes. So forward bias లో వస్తున్న current కి reverse bias లో వస్తున్న current కి there will be 1000 times variation. If it is in milliamperes, it will be in microamperes. There will be around 1000 times variation, and this current remains constant. This changes only with temperature. So at room temperature, if there are 5 electrons, if I raise the temperature, there may be some 10 electrons. There may be some 100 electrons at 70 degrees. Maybe some 1000 electrons at 100 degrees. So like that. This current is purely dependent upon temperature. And remains independent of the applied voltage. మనం 1 volt అప్లై చేసినా 0.1 అప్లై చేసినా సరే ఈ క్యారియర్స్ అన్ని బయటకు వచ్చేస్తాయి. They will simply come out. You don't need to give any extra energy. Even if you give 0.001 voltage, these carriers will come out of the material. Okay, so that is the case. So to measure the band gap of semiconductor, we have to bias the diode in reverse bias. We have to connect the diode in reverse bias configuration. Then only we will be able to deal with the intrinsic charge carriers. In forward bias, we will be majorly dealing with extrinsic carriers, the dopant carriers. So to specifically deal with intrinsic carriers, we have to connect the diode in reverse bias configuration. Okay. So then we go into the details of the experiment. Now coming to the mathematical expression for the number of carriers as a function of temperature. So that number is given by N0 e power minus Eg by K. N0 is the number of atoms in ground state. N is the number of atoms excited to that particular level with a gap of Eg. So Eg gap loki manamu electrons ఎన్ని electrons rise చేయగలము at a given temperature అంటే this is the expression. N0 is number of atoms in ground state. N is number of atoms in excited state. Eg is energy gap. T is temperature. K is Boltzmann constant. So value of Boltzmann constant in electron volts ఒకసారి చూడండి. Search for it. Boltzmann constant. Search the Wikipedia page. into 10 power minus 5 electron volts per Kelvin. So the units entandi it is on one side we have number, here also you have number, so this should be dimensionless. Means the product of K and T should have dimensions of energy. అంటే K కి డైమెన్షన్స్ ఏంటంటే జౌల్స్ పర్ కెల్విన్. జౌల్స్ పర్ కెల్విన్ multiplied by temperature. Kelvin gives you joules. With units of Boltzmann constant is joule per Kelvin. You can convert into electron volts per Kelvin. Joules per Kelvin ఎంత అంటే వాల్యూ 1.38 into 10 power minus 23 joules per Kelvin. So by 1.6 into 10 power minus 19 waste, you get the number in electron volts per Kelvin. Okay, and so once you know the number of carriers, you can get an expression for current. So ఏమవుతుందంటే I can write I is equal to I0 e power minus Eg by K. సో నెంబర్ ఆఫ్ క్యారియర్స్ క్రాసింగ్ ఇన్ యూనిట్ టైం, ఆ నెంబర్ని నేను విత్ రెస్పెక్ట్ టు టైమ్ డిఫరెన్షియేట్ చేస్తే I get this. So now with the rise in temperature, this current rises, and I have to get the value of Eg from this. So indulo I naught is a constant, Eg is a constant, K is a constant, I and T are variables. So this is local constant, this is also local constant, and this is global constant. And in the variables, this is independent variable and this is dependent. So I have to draw a graph between temperature versus current, and I have to get the value of Eg. ఎట్లా తీసుకుని రావాలండి, ఇందులో నుంచి Eg బయటికి రావాలంటే ఎట్లా చేయాలి? Yes, since the parameter of interest lies in exponential, we have to take logarithm. So log I ఏమవుతుంది? Log I is equal to log I naught multiply, right? Plus okay. So ఏమవుతుంది? log I minus log I naught minus Eg by K. So log I by naught. So temperature is one variable, current is the dependent variable. So then graph దేనికి గీయాలి? If I draw a graph between log I versus 1 by T or 1 by T, otherwise 1 by KT. Log I versus 1 by KT, I should get negative slope of Eg. Minus Eg is the slope of this. When y is equal to mx formula తీసుకుంటే, here the slope is minus Eg. So I should get a straight line with negative slope. And if I properly maintain that, if I clearly maintain what is this, log I is equal to minus Eg into 1 by Kt plus log I naught. So my y-intercept is log I naught. So my axis I am taking log y, and one particular number is log I naught. And the slope, if I measure this slope, how to measure that? Take any 2 points x1, x2. This is y1, y2. That is negative Eg. Okay. So ఏం చేయాలంటే, take the temperature and measure the current. To collect data of temperature versus current. అంటే ఏం చేస్తారు, డయోడ్ తీసుకెళ్ళి రివర్స్ బయాస్ చేసి ఒక ఆయిల్ ఇమోషన్ ఛాంబర్లో పెడతారు. and start heating the oil. ఏమవుతుంది, టెంపరేచర్ రైజెస్ అండ్ కరెంట్ రైజెస్. అయితే ఈ ఎప్సిలాన్ మనము ఫాలింగ్ టెంపరేచర్లో మెజర్మెంట్స్ తీసుకోవాలి. ఎందుకనండి రైజింగ్ టైంలో ఏమవుతుంది అంటే మీరు థర్మామీటర్ మే బి స్లో సమ్ టైమ్స్, ఇట్ మే నాట్ రెస్పాండ్ క్విక్లీ యాజ్ క్విక్ యాజ్ ద ఇన్కమింగ్ టెంపరేచర్. సో మనం దాన్ని హీట్ చేస్తున్నాము, ఈ థర్మామీటర్లో 60 చూపించడానికి యాక్చువల్ టెంపరేచర్ 70 ఉండొచ్చు. ఆ థర్మామీటర్లో రీడింగ్ 89 వచ్చేసరికి యాక్చువల్ టెంపరేచర్ 100 క్రాస్ అవ్వచ్చు. సో ఇట్ ఈస్ ఆల్వేస్ బెటర్ to take or note down the temperatures during cooling time. So let the temperature rises up to 100 or 110 degrees centigrade. Switch off the heater. Then wait for a few minutes. Then you start noting the temperature. So temperature starts from, let's say, 100. So 100, 95, 90, 85, 87, 65, 60. ఇలాగ టెంపరేచర్ నోట్ చేస్తారు. So with the fall of temperature, current also falls. So that will be in microamperes. So ఇక్కడ ఏదో 30 microamperes ఉంటే 27, 25, 27, 22, 15. Get some numbers. సో ఇక్కడ మనం తీసుకోవాల్సింది, we have to take temperature in kelvins. సో దీన్ని మీరు కెల్విన్స్లోకి కన్వర్ట్ చేయాలి. ప్లస్ 273. So this becomes 373 and this is 368. Then you have to take 1 by T. అంతే కదండి, 1 by T అంటే ఏమవుతుంది? సో 1 by 300 నియర్ టు 100, 1000, 1003. And this number is falling. So 39, 38, 37. Then let it go for logarithm of I. I is in what? Microamperes, right? So logarithm of some 13 to 10 power minus 6 base E. We'll get a negative number here. Some minus 4 or minus 5 kind of negative numbers we get here. So log I is a negative number, 1 by T is a positive number, and what is the graph? 1 by T value, it should be rising, right? Temperature value may be 0.4, 0.3 నుంచి 0.4 వరకు. 1 by T value rises and log I value falls. So 1 by T value పెరుగుతూ ఉంటే log I value తగ్గుతుంది in a negative scale. So this is minus 5, minus 4, minus 3. One by T is 0.06. 0.003, 0.004, 0.005. Maybe you have to multiply with k also. So then you will get a number. So 10 power plus 5 to multiply చేస్తున్నారు. So you will get this in hundreds. Maybe 200, 300, 200, 300, 400 it goes. So 1 by kt value comes in hundreds. Log I negative numbers. So you have to connect the diode in reverse bias configuration, and you have to immerse it in a oil chamber and you start heating it. Once you reach a particular temperature above 100, you turn off the heater and then record the temperatures with as a function of, you have to record the current as a function of temperature. Done.